breaking ionic compounds into ions, of course you're going to need an ion chart. Okay, get your ion chart. We're going to write the charge of the component ions for each of the formulas below. If there are 3 or more elements in the formula, then the formula contains a polyatomic ion. So you need to look up here to get those polyatomic ions. Okay, so let's look at our examples. We've got 3 or more elements, calcium, sulfur, oxygen. So that means we have a polyatomic ion. So which one's the polyatomic ion? It's this one. So we've got calcium, and we're just going to look on here. He's a +2. And then we've got that SO4, so you're going to go into your polyatomic ion chart and find SO4. There it is. And that whole thing, that sulfate, is a -2. That's all we're doing. We're breaking apart compounds into their ions. This is going to lead us into the next page, which is going to be the word equations. Okay, here's another one. We've got calcium and we've got phosphate. Now, why is the 3 and 2 there? Because when I write a formula containing calcium and phosphate, I swap the numbers and drop the signs. I'm not going to include these subscripts when I'm doing this because calcium's a +2. I know that from here. And then PO4. I go up here. Again, PO4 is what? Phosphate, and that whole thing is a -3. So I put -3 here. Again, no subscripts because that's what I use to write the formulas. All right, and I've got another one here. Here's ammonium. Again, we've got 3 or more elements, so I've got ammonium. Where's ammonium? That's that tricky one that's over here. He's a positive polyatomic ion, so he's a +1, and who's he with? He's with chlorine, who's a -1. So just break these apart into their ions.